a small fishbowl. For the fish inside, this place is the entire universe. They have never seen, nor could they imagine, a world beyond the glass walls. But then someone whispers to them, "There are lakes out there. There are rivers where you can swim freely, and there is an endless ocean with no horizon in sight." How would these fish respond to such a revelation? We once thought Earth was everything, but Earth is only one of 8 planets orbiting the Sun. And the Sun is only one of 200 billion stars in our galaxy. And our galaxy is only one of hundreds of billions of galaxies in the cosmos. We call this grand stage the universe. But is this really the end? Could there be other stages beyond it? The truth is, when we say the universe, one word is left out. What we actually mean is the observable universe. The universe began from a single point of light. And today, what we call the universe is simply the distance that light has traveled since that beginning. In other words, our universe is the space within the reach of light itself. Beyond that, we cannot yet draw a map. Is there truly nothing there? Or is it just something we have not yet seen? Scientists discovered something astonishing. The stars in the night sky are not fixed. They are moving farther and farther away from Earth. No matter how often they checked, the result was the same. Even the distances between galaxies themselves were stretching apart. The heavens were expanding at a speed beyond imagination. Today, this feels familiar, but when it was first discovered, it was pure shock. And when scientists rewound this expansion with computer simulations, everything converged to a single point. We call this the Big Bang. From one tiny point, everything burst into existence. But was that explosion really only once? Let's reimagine the birth of the universe. Scientists say it wasn't just a simple bang. In less than a fraction of a second after it began, the universe expanded faster than light itself, inflating to an unimaginable size. We call this cosmic inflation. Something smaller than an atom suddenly became larger than a soccer ball, and far more. And that is why, no matter which direction we look, the universe appears astonishingly uniform. Such rapid and powerful inflation would naturally explain this balance. But what if the universe had expanded more slowly? One side would be scorching hot, the other side freezing cold. There would have been no time for heat and light to mix evenly. The universe as we know it would have been broken into isolated, chaotic regions. So what does all of this have to do with the multiverse? Here's an easy way to picture it. Imagine you're boiling a giant pot of water. Countless bubbles form. Some grow large, while others burst quickly. Now, what is beyond our visible universe? Inflation is still happening. And within that seething energy, new bubbles are constantly being born? If so, then our universe is just one of those countless bubbles. The bubble next to us would be another universe, and beyond that, yet another, an endless sea of cosmic bubbles. The shocking part is that each bubble universe could follow completely different rules. Just as no two bubbles are alike, no two universes would be the same. In some, gravity might be so strong that they collapse as soon as they form. In others, gravity might be so weak that stars and planets could never even come together, leaving nothing but emptiness. The very laws of physics could be different. Perhaps in some universes, apples fall upward. Perhaps in others, time itself flows backward. Think about it. Our universe seems strangely perfect for life. Is that just luck? The multiverse theory offers an answer. We are not special. Out of countless possibilities, we simply live in one of the rare universes where conditions allowed life to emerge. When we talk about the multiverse, we eventually return to the smallest scale, the quantum world. Here, the rules of common sense no longer apply. Imagine flipping a coin. To us, it must land on heads or tails. But in the quantum world, until the coin is observed, it is both heads and tails at the same time. This is called superposition. So here's the question. When the coin is finally observed, Do all but one possibility vanish? Or do all outcomes actually exist, each in a separate branch of reality? This is the many worlds interpretation, another way the multiverse could emerge. The universe does not follow a single path. Every possibility creates a new branch. Even the choices you didn't make may still exist, playing out in another version of reality. Take a simple example. Did you arrive late to school this morning, or not? In our universe, maybe you arrived on time, but in another, you were late. Every small decision, every outcome, becomes a branching point where new universes unfold. Is this real? Do we have proof? Not yet. But mathematically, the theory is consistent, and experiments already confirm that superposition is real. Quantum computers themselves work by holding many possibilities at once, a sign that quantum superposition is not just theory, but reality. This is why quantum mechanics keeps appearing in multiverse discussions. If quantum possibilities are real, then we might truly be just one universe among countless others. But then comes the ultimate question. Why are we in a universe so perfectly tuned for life? If gravity had been even slightly stronger, stars would have collapsed instantly. If it had been weaker, stars might never have formed at all. The conditions we live in are astonishingly precise. The multiverse hypothesis answers this too. If countless universes exist, most of them cannot support life. We happen to be in one of the rare universes where life can survive. It feels like luck, but in reality, life could only exist in such a universe. Scientists call this the Theanthropic Principle. But is this still just speculation? Not entirely. Scientists are actively searching for evidence. In the faint afterglow of the Big Bang, the cosmic microwave background, or CMB, they look for unusual cold spots or strange patterns that might be scars left by another universe brushing against ours. If inflation really happened, it should have left behind tiny ripples, primordial gravitational waves that still echo faintly through space. Sensitive instruments are already scanning the skies, trying to capture them. And even the vast distribution of galaxies may hold unexpected patterns, clues that point to realities beyond our own. If such signals are ever found, then the multiverse will no longer be just imagination. It will become science, measurable, observable, and real. So let's step back and summarize. The universe we see is limited to the reach of light today. We cannot say what lies beyond the horizon. Inflation suggests new universes could be born again and again. Quantum physics opens the door to endless branching possibilities, and the precise values of physical constants hint that other rules, other realities, could exist. We do not yet have proof, but these are all questions that science can test, with observation, with data, with relentless curiosity. The truth is simple. We live inside the glass wall of our observable universe. Just as people once thought the edge of the ocean was the edge of the world, only to discover new continents beyond, we too may discover that the cosmos is far larger than we ever imagined. Is the universe one or many? The answer lies in the sky above us, waiting to be revealed as our instruments grow sharper and our maps of reality expand. For now, we know this much. We live within the boundary of what we can observe. Beyond it is still unknown. And the next chapter begins when the unknown is finally seen, and the map of the universe grows once more.